I keep forgetting. Now we're recording? Is this recording? Now, yes? Okay, cool. I do not understand this, how it works. And you can see my screen, right? Okay, cool, nice. So my plan is we'll talk about what I did not finish. We never ever get to do this, which is field. Field is probably one of my favorite part in this whole course. 102 is not doing a very good job at teaching this. I have to say this because we are not. In this course, it's not as fun as it's supposed to be. Field is super fun. And I hope you can like fields after we talk about this. I'm not forced to say this. I took another field. So I took another field course at UTM. I absolutely love that course. It's super fun. I don't know why people don't understand. It's super fun. 102 is fun. It's 401. 401 is super fun. Anyway, let's do this. Field. So what you need to know is we have two operations. Okay, two operations. One is addition. The other one is called multiplication. We just call them addition and multiplication. It's not like they are actually the usual addition and multiplication. They're just two operations. Does that make sense? They're just two operations. Sometimes they are not usual addition and multiplication. For example, it's starting to come. For example, some of you might already see 1 plus 1 equals to 0, right? You already know 1 plus 1 equals to 0, you 4-element field. So in usual addition, we would never have that, but we still call it addition. So that's what I meant. The addition and multiplication, they might not be the usual addition you know. It might be something that's weird, but just remember they have to satisfy something below. So that's what you need to know. And two special distinguished elements, 0 and 1. That means those two elements, they are not the same. They are distinct elements. Okay, they are distinct elements. Those two. And also those two elements, they are not necessarily 0 and 1. Okay, I know you're getting confused again. They're not necessarily 0 and 1. We are just using 0 to represent our additive identity, and we're just using 1 to represent our multiplicative identity. So in some certain fields, like when we are, for example, we are not just talking about numbers. So it really depends on what your field is. Does that make sense? It depends on what your field is. So for example, in a field that is not dealing with numbers, then your additive identity and multiplicative identity might not just be 0 and 1. It might be something else. Okay, so you need to understand this. They are just your additive identity and multiplicative identity. So those two, they just satisfy this condition. Then we call it the identity. That's all it matters. And then the first one is called closure. Closure means if you have two elements from the field, okay, then if you add them, it's still in the field. If you multiply them, they are still in the field. Now, remember, we have addition, we have multiplication, but you don't have square root. You don't have such things, okay? You don't have square root. You don't have something weird like, I don't know, to the power of 1/2, to the power of 1/3, something like that. We do not have those operations. So we only have addition and multiplication. So that's what you need to know. So x plus y is in F, and x dot y is in F. So one example that you can think about this. Why is this useful for certain questions? Yes, x times x, you can use it as x squared. Yeah, because it's just multiplication. Like to the power of something, if the something is an integer, not like 1 over something, if it's not a fraction, it's just integer, then it's basically multiplication. Is natural numbers a field? What do you think? Does it have 0? You have to have those two. No. Okay. See? And does it have inverse, like additive inverse? Okay, there are many things it does not satisfy. In this course, mostly we're just talking about number field, which means you only have numbers in there. So in this course, most likely you'll see 0 and 1 being your additive identity and multiplicative identity. So using number field as an example for closure, for example, if you know 1 is in field, this implies 1 plus 1 is also in field. And if it's UU addition with 1, you can get all the integers. If it's UU, again, if it's UU addition, you can get all the integers. So for example, if they ask you, oh, 3, is 3 in the field? And it's like UU addition, then we'll definitely ask, because 1 plus 1 plus 1, it's definitely going to be in the field by closure. So that's what it means. Okay, does that make sense? We're doing step by step to make sure you understand everything. So that's closure. State what type of addition. Yes, it will state. So it will tell you, for example, we're doing UU addition, something like that. Okay. You had it in the 1 plus 1 plus 1. Okay, step by step, 1 plus 1 is gonna be in the field, right? So you know this is in the field. So you know 1 plus 1 is in the field. Since this is in the field, you add another thing that's in the field, that's still gonna be in the field. Does that make sense? UU addition is the addition you know. So for example, 1 plus 1 equals to 2. So you know the operation you're working on every day. What other types, they can define it in a weird way. Depends on how they define it. But the ones you will see in this course, they are really not weird. It's just something really, you always know 1 and 0. So those two have to be in the field. So the smallest you can get is like 2. Okay, that's what I want to say about closure. Associative should be simple enough. Okay, make sure you know the names, by the way, because when you do field questions, you need to refer to the field axioms you are using. So all the names, you definitely should know them. So closure, associative, cumulative, additive identity, multiplicative identity, inverse. So we have additive inverse, we have multiplicative inverse, so and distributive. So all those names, you should know them. Whenever you use them, you need to reference them. Associative is just the same as in the real numbers. Commutative means you can switch order. Identities means additive identity means if you x plus 0 will always give you back to x. And multiplicative identity means x multiplied by 1 will always give you x. And the inverse. Inverse, we have, you need to cite field axioms. That is correct. So whatever you use, you need to cite it. That is a great question. I was about to mention that. So read this. For any x in F, there exists W in F such that x plus w equals to 0. So this w is the additive inverse of x. So if x adding another number equals to 0, okay, then this another number is the additive inverse or negative of x. So we write it as negative of x. So this is what you know already. The multiplicative inverse has a condition that it has to be non-zero. So 0 itself has no multiplicative inverse. It has to be non-zero element for it to have a multiplicative inverse. Did I answer your question now? Will the recording, hopefully whenever it's up, I'll post it. Okay, cool. So this is quite important because, okay, because every time non-zero is referring to the additive identity. No. Non-zero is a multiplicative identity. Is this. So using a language that you know it's the same as you cannot divide by 0. Does that make sense? That's the language you know. You cannot divide by 0. So 0 has no inverse. Make sense? So that's what I want to mention. Every time, okay, listen carefully. Every time you want to use inverse, you need to tell me it exists because we know that it's non-zero. Does that make sense? Because if you don't mention that, you might lose mark. Okay? So for example, I want to multiply both sides by x inverse. Then I need to say, because we know x is not 0, x inverse exists. Okay, that's why you can multiply. So that sentence is quite important. That's about multiplicative inverse. And lastly, we have distributive, which is exactly like in real numbers, where you can distribute things stuff. Okay, so this is filled. Along with the axioms, something else you can also use are the ones that's proved in lecture or in the course notes. Can we just say existence of, you need to mention that it's because it's non-zero. So for example, you want to multiply both sides by x inverse, you need to say because x is not 0, we know x inverse exists. You need to emphasize the non-zero part. Otherwise, you don't, do you have to prove, you don't need to prove it's not 0. If it's not 0, it's going to be given to you, right? In the question, it will say x does not equal to 0. Okay, so that's what I want to mention. That's one of the things that people always lose mark. They did not mention that it's because it's because it's not 0. That's why we have inverse. Okay, so that's one of the parts. Another thing you can use, okay, listen carefully, you can use, what you can use is for what's it called, is for for x in fill, x times 0 equals to 0. So this one, I believe it is proved in the course notes, so you can use it directly. Okay, you can use this directly. What if you negate? What do you mean negate? As like logic negation? You cannot use logic yet. Claim 2.3. Is this 2.3.2? Yeah, okay, so this is 2.3.2. So you can use it directly. What's 2.3.3 then? Is that AB equals to 1? Okay, so yeah, that's the one I was gonna say. You can use that one as well. when do I have AB equals to 1? For how many elements? Anyone remember? 4 element, okay? This is quite important. If you are given a 3 element field, then it's not true. So let's say let F be a 4 element field. So F is like 0, 1, AB. Then AB equals to 1. Okay, so this, you can use it directly as well. So along with the 6 axioms, you can also use the 2 claims we have. Okay, so those 2, you can use them directly without proof as well. So that's about field. Now let's try a question. So F is a field. Prove that if, oh, by the way, this is what I want to say. Really important. Do not skip steps. Do not skip steps. In field question, you cannot skip a single step, okay? You have to do them step by step. For example, if you multiply both sides by something, then you do it, then you cannot switch order immediately. Do this, scroll up. Yes, you need to state each axiom property you use for each of the steps. Okay, so it looks really simple because if you look at this, you see, oh, we just cancel out those 2, right? Simple. It is simple. However, you need to use the axioms step by step. Each step, you can only use like 1 axioms. Well, you can use 2 axioms if it's like 1 on this side, 1 on this side, that's okay. But each step you should not skip steps. That's what I meant. Okay, so let's try this. Proof. We know that our how to deal with this is we want to use that inverse to cancel out those 2 z. So that's what we need to do. So let's suppose x dot z equals to z times y, and z is not 0. Okay. Then by multiplicative inverse, we know that z inverse exists. Z inverse exists. It's better that you do that. It's definitely better you do that. Okay, so we can multiply both sides by z inverse, but make sure you know this. When you do multiplication, you can either do both on the left hand side or on the right hand side. You cannot do one left, one right, or put one in the middle. That is not allowed. Does that make sense? So basically, I want to multiply z inverse on both sides. So I'm gonna do this. Z inverse equals to z, y, z inverse. Does this make sense? So I multiplied z inverse on both sides. Okay, so what I meant is you cannot do, so do not put this here. Like, I mean, not there, I mean here. Do not put it here, okay? Because you're not there yet. If you use that, you're skipping steps. I can choose the other side. I can multiply both sides on this. So if you want to move it to here, then you need to move both here. So you either choose left or you choose right. Okay. You cannot put them in the middle. Middle is never allowed. Either left multiplication or right left multiplication. So of course you can say you use associative here, but I actually didn't really use that, but it's okay. Let's say we used associative. Now I want to cancel out those two terms. So I'm gonna move it. This is where I actually used associative. I'm gonna put those two as well so I can switch the order later. Oh, okay, so this is associative. So basically I just switched the order of my brackets, didn't do anything else. It's only associative. And then I know those two will give me 1, right? So I'm gonna make those two 1. So this is the same as x times 1 equals 2. And on this side I'm gonna switch the order. So this side I used multiplicative inverse. And commutative. Okay. Why is the previous associative? Because I switched the order of the brackets. Basically this. Does that make sense? Because I added brackets basically. I didn't really use this. So I'm kinda tempting to cross it out because I didn't really use it. Okay, let's cross it out because I didn't really use it. Whatever. Why do I use commutative? Shouldn't be associative. The commutative is because I switched this. Uh, I don't think we're that strict, but sure, you can say on the left hand side and this on the right hand side, sure, to be perfect. I don't think we're that picky, but okay. Some TAs are quite picky, so let's be perfect. Sure, why not? Okay, so this is what we get here. And try to answer each other's question in the chat because you guys have too many questions. And if I answer everything, it's gonna take forever. So try to answer each other. Okay? And this side is gonna give you, and this side I wanna put those two together. I feel like this is kind of stupid. I should have done it in another way, because then I would have more explanation. I should have switched those order and then do this at the same time. This is bad. I'm making a bad decision, but okay. I feel like I'm making a bad decision because I could have put them together. Not sure if you know what I meant, but okay. It's okay. So I'm gonna put those together and then y. And need more space for explanation. So on the left hand side, we used multiplicative identity. And right-hand side, we use the associative. Okay. And then this side stays the same. So we have x equals 2. This will give you 1. So this is a multiplicative inverse. And x equals to y. The last one is multiplicative identity. And then we're done. That's it. That's the end of the proof. Does this make sense? Okay, cool. Hopefully you guys can do something like this if you see it. So slow though. It is slow. Field questions are all like this, unfortunately. Why is it exist? It is here. It is here. What do you mean I didn't mention it? Writing like this, yeah, that's okay. You can do it like this. Oh, they meant they are elements of F. They didn't write it down, but that's what they meant. Multiplying both sides by the inverse of Z. This multiplicative inverse. I know it exists, so I can multiply them. Like here. Okay, let's see a slightly harder question. Last year's quiz. Let F be a field and XY be elements of field. Suppose that X is not 0. I feel like whenever you see this, you should immediately think that, well, we have X inverse exists. And you definitely need to use it, right? So that's a trick. You see this? Well, we have this. Prove that there is an element R in F such that XR minus Y equals to 0. So I want you to think about what you need to prove, because this sentence, it's kind of confusing you. So once you figure out what you actually need to prove, you're basically done. So use the time, think about what you need to prove. What you need to do, think about what you need to do. Keep thinking, and I'll give you the answer later. Just keep thinking. Read this carefully. Just keep reading this, guys. Keep reading this, and you'll figure it out. Does it not remind you of anything? Prove that there is an element in something such that something. Have you never seen that before? So when you saw this before, what did we do? How do we prove there is an element such that something? The answer is right in front of you. What do I need to do? No, 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 not image. We saw it in the image proof. Where did we see it? We saw it in the second half of image proof. And for the second half of the image proof, you need to prove that there is an x, there is x in a domain such that f of x equals to y, right? Prove the existence of x. How did we prove the existence of x? That's my question. How did we prove the existence of x? You find x, right? You let x equals to something.
We find the inverse, right?
You find x, right? So when they ask you to prove there exists something, then you find r equals to something, something. So that's exactly the same as before. So the answer is right in front of you. There is an element r means you need to find r equals to something, something. And then you plug in your r in this equation to show that it equals to 0. Does that make sense? So it's exactly like before, it's just you're ignoring it the whole time. Okay, so this sentence, you've seen it before, you know how to prove it, but you just didn't notice that. Also, in the field part, do not use fraction. Use the inverse symbol, do not use fraction, okay? Yes, exactly, then you are correct. So now you know how to do it. So what is my R? Okay, I know people are sending the solution in the chat already, so, but now ignore the chat. You think about how do I find R? What is my R? Does that make sense? The formal way to do it, they should have written it as this. But it's okay, whatever. Okay. They meant negative y because we've seen negative as well, like negative x. So that's what they meant. R is an element in F, and you want to express it as a function of x or y, or not function. Try not to do that. That's what I'm gonna say. Because when professors do this, they don't lose mark, but when you do this, you might lose mark. You know how it works. It's nobody's fault. It's that you guys are just learning it. So you should use something formal to make sure we can make sure you understand the material. The professors, they've been doing this for a long time. So they are extremely experienced and they know what they're doing. So that's basically why. We're trying to make sure you know how to do it properly. Okay, so what is my R? What is my R? I let R be. Okay, we let R be x inverse y. That is true. Okay, that's what we do. And then you plug in back to this and see if you get 0. Basically, that's all you need to do. Does that make sense? So the whole thing is to figure out what you need to do. It's an easy question. It's just you'll never figure out what you need to do. So you're trying hard in the wrong direction, which is really sad. Okay, let's try this. Now I'm pretty sure you all know how to prove it. So proof, we want to let it be x inverse y. So we want to let it be this. So we need to say that this exists, right? So suppose okay, so we need to, so what do I start? Where do I start? So I'm gonna suppose x, y are in F and x is non-zero. And you can say by multiplicative inverse, we know that the inverse exists. Multiplicative inverse. X inverse exists. So we know this exists. Now let R equals to X inverse Y. We know this is definitely in F. Why? Because closure. We know it's in F. Okay, so now we need to show, now we only need to show XR minus Y equals to 0. So that's what we need to do. So let's start with the left hand side. XR minus Y is basically, well, let's just write it as this, equals to X. R is X inverse Y, and then plus negative Y. So that's our first step. You sub it in. Okay, you sub it in. And the next step, you're gonna put those two together, so that's associative. So this is associative, which equals to 1 times Y plus negative Y. Oh, this looks bad. So this is multiplicative identity. And Y times, 1 times Y is Y. Oh, I wrote it wrong, sorry. Don't know why I wrote identity. Should be multiplicative inverse. The next step is identity. Wait, what did I do? Associative? I think I wrote it in the wrong. So this step is associative, yeah. This step is from here to here. So that's multiplicative inverse. And from here is identity, okay. Because I was trying to make sure I'm doing the right thing. Identity. And now you want to add them together. This is the additive inverse of this. So that's gonna be, what is this? What do we get? 0, exactly. So this is additive. What is this? What is this called? Identity, exactly. Wait, this is not identity. What are you talking about? This is not identity. What is this? Additive what? Inverse, exactly. You can also write it as negative if you want to, because they define it as negative as well. So you can write this as reciprocal and write this as negative. Okay, then you're done. So this proves, done. I don't want to write the conclusion. This is done. Do I need an axiom in the first line, like here? This? Not really. It's basically the same thing, except they're not doing the formal way. This was actually a quiz question, and people did not do well. They did really bad. Last year, they did really, really bad on this. This is the time, like, is to find, or do we just leave that part as rough work? Yes, that's just rough work. And you only need to state what your R is. Yeah, just like in the image question, it's exactly the same idea. There was a really hard question last year. You've seen all 3 questions from last year. Which question is hard? I have no idea. I don't know what your quiz looked like. Can you explain how we got this? It's basically it's basically the same thing. Y over x is the same as yx inverse or x inverse y, except for field you do not use fraction because we don't have division, we have inverse, multiplicative inverse. I mean, it's the same idea as fraction, but we do not have that. Does that make sense? Uh, I don't remember who DM'd me about that. Let me know if that makes sense to you. What happens if you don't get the email you email Marina? And oh yeah, what happens if you don't get the email you email Marina? What happens if Quadmer doesn't let you submit? You email me, okay? You email me directly before the deadline because we do not accept late submission. Do not submit on your phone. This is what I said. Do not submit on your phone. Try to do it on your laptop because phone is never good. Because last quiz, not quiz, yeah, last quiz, someone tried it on phone. Although I said do not do it on phone, someone tried it on phone, and apparently on their phone it says they submitted, but it failed, and there is no evidence that they did that, so we cannot do anything about it. So this is what I said: do not submit on your phone. You take pictures, that's okay, but you submit on your laptop. It's a safe option. It should be 6 p.m. sharp. Yeah. You can submit more than one question. I think you can submit more than one document per question. Yeah. Are we continuing until 11 p.m.? I'm continuing till I finish the questions we need to do. Okay. Today's material. We're not done yet. We're not done yet, guys. We are not done yet. 4. Do you guys want to try 4? What about this? Try 4 yourself and see if you can figure it out. It should be fairly easy, but try. Now try. And if you want to write on the board, you can do that. I'll let you write if you want to. So you can annotate. So yeah, just annotate and see how it goes. You few people can do it at the same time. Like for example, if you don't like what the other people wrote, you can do it your own version. Example 3 was this. Back to here. Like this. Question. What is your question?
Oh, I just had a quick question for these type of questions, right? We always solve from then and then make our way to.
Solve for what? Done?
So okay, so like we have then x equals y, right? So we start like for the proof, we start from there to the and work
No, no,
backward.
no. You. This is
Oh no,
what.
that's for the rough work. Oh yeah, never mind.
This is what's given. This is given.
Yeah.
This is what you need to prove.
Okay, okay. Thank you. I just had it mixed up from the rough work part. My bad.
Why do we have y inverse? Again, I just said you need to show me why does that exist, and now you're not showing me. You just lost half mark. Hopefully, with all of you together, you can get full mark. So I'm not gonna comment for now, and let's see if you guys together, all of you, and let's see if you can get full mark on this question. Yeah, by the way, you can type. You don't have to write if that's a problem for you. I see a hand raised. You can just unmute yourself and talk. The upper examples, that example, I'll post the video and the solution on Quarkus, don't worry. Okay, so the rest of you read what's written on the board and see if you think whoever's writing can get a full mark. So let's see, prove that. Okay, so we started from this. We have y inverse exists because y is not 0. Okay, nice. Someone added multiplicative inverse. That's great. What's missing from the proof, guys? What's missing from the proof? You're not gonna get full mark. So someone add something and see if we can get full mark. And it seems like you guys are skipping some steps, which is not good. Anyone want to add the steps people skipped? Don't skip steps, guys. Do not skip steps. That's Jeff, that's skipping a lot of steps. What you did is skipping a lot of steps. It's okay, I'll erase everything and I'll write it again, don't worry. Right now, we're just criticizing their proofs. This is basically what I've been told to not to do during the TA training day, but who cares? Okay, let's see. This is really messy now. Are we done now? I see people are adding stuff. Okay, so we have, oh, I'm gonna use my own. I'm gonna add stuff. Okay, so we have, now we're drawing. We have, since y is not 0, but multiplicative inverse this way is this, that's correct. And then you multiply both sides by y inverse, okay? That's good. And x minus y, okay, so someone added this, okay, cool, now that's great. what, so what axioms did we use here from the oh, why is a straight line? I feel like I don't know how to use this. So, oh, this is weird. This is weird. I don't know how to do this. Okay, so from this step to this step, what did we use? Claim 2.3.2, exactly. Nice. Oh, someone wrote it here. Sorry, I didn't catch that. It's too messy. That's great. That's great. And we have x something x minus 1. Oh, I see. I think it's because I moved it a bit. Oh, so I see. So someone wrote here is x, here is x minus 1 y multiplied by 1 equals to 0. That is correct. What do we use here from here to here? I have no idea what's going on. So I'm gonna erase something and rewrite it. So originally we had x minus y. Oh, this is so hard. Multiplied by 1 equals to 0. What do we use here? From here to here, what do we use? Multiplicative inverse, exactly. And then this is y, by the way. It looks like an x, but it's y. Oh, I'm making it worse. This is killing me. Oh, no. Okay, this looks better. What about from this step to this step? What's going on here? Did we miss something? Skipped, exactly. Something's wrong here. How do we get this? You need to write x minus y first, and then you write it as x plus minus y. Does that make sense? So now I'm gonna erase all those. You can still draw, but I'm gonna erase the messy work. Just draw the places where I'm not writing. You can do that. Hopefully you can do that. So I'm gonna erase those. Sorry guys. Kind of cute, but I have to erase so that we can write something. Why is it taking forever for me to erase everything? Okay, I'm gonna clear everything. You can draw again. Clear everything. Clear. Oh, someone typed up a proof. Were you typing this up the whole time? Let's see. Nice. Let's see. Before I write anything, wow. Okay, that's impressive. Let's see if you can get full mark. Okay, whoever wrote this, I don't know who you are because I can't tell. X minus y multiplied by y equals to 0. Since y is not 0, x inverse exists, okay? X plus negative y multiplied by y times y inverse equals to this, okay? Okay, cool. And stop adding check marks everywhere. Okay, x plus negative y multiplied by 1 equals to 0. Existence of reciprocal. Here you should also say use the claim. So use the claim because 0 multiplied by everything is something. It's not wrong. It's not wrong. It's just missing something. Okay, it's not wrong. Okay, and just adding stuff here in this step. And then the next part is x plus negative y equals to 0. This is multiplicative identity. That's correct. And then we're adding y on both sides. Add y on both sides, okay. And then we have x plus 0 equals to 0 plus x. So I suggest you to add brackets here so you will know you're doing this step first. So you should use associative here. So add one more step, put brackets here, use associativity. It's not wrong, it's just missing something. Come on, let's not be too harsh, okay? And x plus 0 equals to 0 plus y, that's correct. That's the existence of negatives. Not really existence of negatives. So here I will change this. So what did we use here? Guys, what did we use here? This is not an axiom. Yeah, you don't need this. Oh, what happened? I'm freaking out. Oh, it's just my iPad. Oh no, is everything gone? Oh, they're back. They're back. They're back. Nice. I thought everything's gone. Oh my god. Okay. Nice. We're good. So what did we use here, guys? What did we use here? Oh. Here, what did we use? This step. What did we use on this step? We used the additive inverse, exactly. No, yeah. We used the additive inverse. Oh wow, what just happened? I do not know what just happened. But okay. I don't know what did I do. I don't know why they're back. Anyway, and the last step is additive identity. Okay, so this is good. So if you add the steps I mentioned, then everything is good. Let's say if this question is out of 4, what do you think this person can get? Be fair, guys. Be fair. Be fair. Try not to troll. Okay, I would say if it's 4, we will probably give him 3.5. But if it's 3, I'll probably give this person a full mark. Okay? What did he miss? Oh, wow. First of all, this is not existence of negative. And he skipped a step somewhere. I don't remember. Oh, here he should add another step here to put associative here. Okay, so if it's like 3, then I would say I'll give you 4 mark. But if it's out of 4, I'll probably deduct half mark. And that's being quite harsh already. So being harsh, I would say I'll give you 3.5 out of 4. But being nice, I'll just give you 4. Most likely we'll just give you 4, to be honest. I'll tell the TAs. I'll tell the TAs to be nice to you. So is Daria as nice as you? Daria is my best friend. She's my love. Me. Put a heart here. Daria is my love. Heart. Daria. For Daria. We're best friends. Okay, so do we have any question for this question? Question. My boyfriend, he's my love as well. I can have more than one love, come on. Daria has a lot of love too. She calls everyone her love. Not everyone, her good friends. Oh wow, I don't know what's going on right now. Okay, I'm gonna clear everything. Oh, someone said, could you clarify the steps the solution is missing? Sure. The steps the solution is missing is, okay, people stop writing. Let me explain this and then you can continue, okay? So here, oh, why? Oh, I'm confused. Hold on. So here, they should add another step to put those two together. So that's associative. And here, this is not existence of negative. It's called additive inverse. Or you can call it or you can call it negative, but it's not like existence of negative. It's because it's just, or it doesn't really matter that much. The whole thing that's missing is many just here. So many just here. So from this step to this step, you should have one more step here. Okay. Any other question? There is another one. I do again. I do not know what's on your quiz, so I don't want to say anything about that. So don't ask me if it's gonna be similar. I do not know if it's gonna be similar. Hopefully, but I do not know. I actually don't know. Okay. Okay, I'm gonna clear everything. Clear. And let's look at another question. Oh, I'm really bad at this. 5. Okay, you can play with this one again. This one is a long one. This one is a long one. If we want to bring something over from left-hand side to right-hand side, do we need to clarify it, or it's best to subtract? Yeah, you should subtract or adding something to both sides. You should not just remove something directly, because that's not how we do it in field.
For this question, do we have to use 2 times 3 instead of A times B?
2 times 3. Hold
Because
on.
it's
Did I,
0, 1, 2, 3 in the
it's
field.
0, 1, AB. Sorry, I typed it wrong.
Oh, okay.
It's a typo. It's just I'm too used to 1, 2, 3. Let me fix it. I'll fix it. Don't worry. So should be AB. Oh wow, scared me. Uh-oh. What's going on? B. Okay, there we go. What will happen if we did not separate negative y2 plus negative y? It's just a joke. I won't hunt you down. I'm just kidding. You you might lose mark. You might lose mark. It's basically closure. If you have to say or adding 2 sides is allowed. It's basically the adding adding 2 sides or adding something on the 2 sides or multiply something on 2 sides. As long as they are in the field, then you can do that. Square means a multiplied by a, so it's just multiplication. Yeah, it's basically multiplication, so it's okay. Anyone want to write your solution? You should try to avoid contradiction because you're not there yet, and we can deduct mark for you if you use it. How would you begin? You guys, how would you begin? What method do I use? Elimination, exactly, elimination. Elimination. So you want to show it equals to B, then you want to show it's not 0, it's not 1, and it's not A. Not 1, not A. Once you've done that, then you're done. No, it's not contradiction. Contradiction is different. Elimination and contradiction are not the same.
I had a question because like in the answers for 45, they didn't like elimination, right? And when they solved it at the end, they said no, that's a contradiction. So that's why that's false.
No, oh, that's what you meant. That's
Yeah.
what you meant. This is not proof by contradiction. So the contradiction we're saying is just like in English, they contradict with each other. What I'm saying is you should not use proof by contradiction. Does
Oh,
that
okay.
make sense?
Yeah, so we can still eliminate it and say that contradicts the
Yeah,
statement, but it's
you
not
can
proof.
still say, oh, this is not possible, or this you can say that, but you're not using proof by contradiction. So you're not saying, oh, for yeah. So proof by contradiction in this case will be you suppose A squared does not equal to B. That's proof by contradiction.
Oh, okay,
Suppose
okay.
the
Yeah, that makes
negation
so
of
much more
this.
sense.
So that's the difference.
Thank you so much.
No problem. Basically, you try to avoid it, but even if you use it, I'll try to let it slip. I'll try to ask them to be nice to you, but I can't guarantee anything. People would try to be nice to you, but I cannot check everything. Someone pinged me. Who is it? Does UTM have an organic chemistry course you can take? There are many organic chemistry courses. No one wants to write your solution? That's too. Use another pen, please. You're gonna take all the space once you finish. Okay, let me see. Someone said, can we use calculus? No calculus. No calculus. What's understanding that what A does not be what? I do not understand. Mark, what is your question again? How we added y or minus y on both sides, you can add any field element on both sides as long as they are in the field, or you can multiply any field element on both sides. It just the equality stays the same. It's basically you just need to make sure what you're adding or multiplying, they are indeed in the field, and you want to make sure want to make sure you're adding to the same side, like same size as like left multiplication or left addition, right addition, like that. Yes, you can say that because it's a field with 4 elements, so 0, 1, A, B, they should all be different. They should all be different. They should not be the same. Yeah, try to do different cases, each of you, so we have a full complete proof once you're done. Oh, one of you only wrote QED. Are you gonna do that? Are you gonna do that on your quiz? You can't read this art. It's okay. We'll read their art. We will read their art first, and then I'll write down a formal proof. Okay? I do want to see what people are doing. Okay, so hi, we've been trying to reach you about your car extended warranty. I haven't got any scam call for a while. You know, the air their air duct cleaning thing. You got one today? I usually don't answer any unknown. Yeah, air duct cleaning. They used to call me all the time. I don't know why they stopped. Okay, that's enough. Okay, everyone stop. Stop, 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 stop. I'm gonna stop letting you annotate and we're gonna talk about this because I don't want them to keep going. So let's see what we have. Let's see what we have. So we need to discuss three cases. A square is 0. So this is a square equals to 1. Okay, so let's look at this. Let's look at the brown part. So a equals to 1. What is your, so b equals to 1 times b. Okay, so a times 1 equals to 1 times b. So here, oh, never mind. I should draw something. So here, from here to here, you should add on one more step, put A, B together using associative, and then A equals to 1, which equals to 1 multiplied by B. So that's going to give you 1 equals to B. Does that make sense? I will write it out later after we read this. Don't worry, I will write it out later. So that's the first part. Let's look at this part, and let's look at this part. If a times a equals to 0, then we multiply both sides by a inverse. Okay, and then we have a inverse equals to 0. Okay, cool, nice. And then this equals to a times 1. Okay, nice, which is 0. So a equals to 0. Okay, nice. So this is pretty good. And you talked about a inverse exists. That's pretty good. So now we know a squared cannot be 1, cannot be 0. What about a? Where is a? A is here. Okay, let's look at this. If a squared equals to a, then you multiply a inverse on both sides. And seems like it's not finished. You multiply both sides on same side. Again, you use associative after this step. Okay, and then this will give you 1. That's correct. So a1 equals to 1. So a equals to 1. Correct idea, just add some axioms next to it. Looks pretty good. So let's write the formal proof. I'll write the formal thing because people cannot read. Is a multiplicative inverse allowed if we do not know whether the element is equal to 0? In this case, you can use it because, well, you know A cannot be 0, B cannot be 0 because they have to be different. Does that make sense, Tony? You know they are not 0. Well, if you do not know, then you cannot use it. But in this case, you know because they have to be distinct elements. So proof, we want to show, we actually, let's say we show that A square cannot be 0, 1, or A. So, and since F is a field, we must have A square equals to B. So that's what we need to do. The first case, we're gonna do A square equals to A. So suppose A square equals to, let's start with 0 actually. If A square equals to 0, since A is not 0, A inverse exists, we can multiply both sides. So A multiplied by A inverse equals to 0 multiplied by A inverse. Okay, and associative, just gonna do this. And this will give you A1 equals to 0. And this, so the left side is multiplicative inverse. And the right side is a claim. What is a claim number again? 2.3 point something, 2, okay. Nice. So this side will give you A equals to 0. So this is multiplicative identity. All right, so this is impossible. This is impossible since we must have 4 distinct elements. Okay, so let's see the chat and see if there's any question. Do I need to write multiply both sides by A inverse? Is A inverse is a symbol, so I don't need to say that. You don't need to say multiply both sides by A inverse. It's pretty clear. You don't need to say that. Can we say this is a contradiction? Yeah, you can say that. Distinct elements mean they are different. They are different elements. They cannot equal to each other. Yeah. Okay, so this is the first case. The second case, so now we know, hence A square is not 0. Second case, suppose A square equals to 1. How do we know? Because A is not 0. Why is A not 0? Because we have 4 elements, so they all have to be different. Okay. Now, suppose this is 1. Then what do we have? By claim, I want to use AB equals to 1. So let's 2.3.3. right? Someone confirm. Is it 2.3.3? Yeah, okay, cool. We know AB equals to 1, so we have A squared equals to AB. So now I'm gonna multiply A inverse on both sides. Again, we know, so I explained it here already, so I don't need to do it again. I know A inverse exists. So A inverse, sorry, A inverse AA equals to A inverse AB. Okay, and I'm gonna put brackets. So this is associative. And then this will give you 1 times A equals to 1 times B. This is a multiplicative inverse. And then this will give you A equals to B. And this is a multiplicative identity. Okay. You can just say we know AB equals to 1 from textbook. You don't have to say 2.3.3 specifically. So this, again, this is impossible. And the reason is just as before, so we don't need to say it again. So we know that A squared is not 1. The last case is A squared equals to A. Then you multiply both sides by A inverse again. And then you use brackets to calculate them first. Oh, what did I do? I don't have another A here, sorry. Associative. And then this will give you 1 multiplied by A equals to 1. That's multiplicative identity. Oh, I'm lazy. Okay, I feel like I'm getting impatient. All right, and then this is A equals to 1. This is, wait, this is not identity. I mean, this is identity, and this is supposed to be inverse. So let's put it here. Inverse. And again, this is impossible. I don't know about you guys. When I write my test on iPad, I just keep copy pasting, copy paste, and change a little bit. I'm too lazy to do the writing. So change this one to A, then you're done. Okay, so this is impossible. So A squared is not A, therefore has to be B. And we're done. Question. It's not identity. We didn't use any identity. It's a definitional field. Then why is it impossible? Because we have 4 distinct elements. B is one of the elements, one of the 4 elements. Yeah, basically those type of questions, I think they're really easy. That's why I don't understand why people think field is hard. This is fun. Yeah, I think it's fun too. Down. How do you know when they ask you to prove something equals to, like, for example, I don't know. So before you leave, I think we should end sometime soon. But before you leave, I want you to make sure you know how to do the following questions. Okay, so let me get it first. How do we put it in our solution? Oh, so hold on. I need to find what I want. So let's see. So where is the question I want you to see? Down. Oh, I'll get there. I'll show you. Just okay, here. So for set questions, I want you to be able to do this type of questions. Okay, do you guys see? Yes, okay, because this involves Cartesian product and this is Cartesian product. So when this question was on the quiz, a lot of people did not do well. So I want you to make sure you know how to do this. That's really important. Make sure you know how to do this because I don't have a lot of time to do all the questions. So 2, 3, try those two, okay? 2 and 3. 2 and 3, try them yourself and then you can have a look at the solution. And also for field questions, I think I did one question that's really good. I do not know where it is now. Let's see, I don't think it's here. It might be here. So let me have a look. This is induction. Doesn't look like it. Spoiler. You don't need to know this. This is contradiction. So don't worry. This is contradiction as well. This is a field question. Where was the video about the set? I think it was 4. I don't remember. Where is my field question? Ah, sorry, I'm really not patient. This question you guys should try it as well. This one. This. Do you guys see 5? So write it down, people. Someone write it down about the questions I said you should try, and then send it to others if you're nice enough. So I'm still looking for the field question I mentioned. Not this. Not this. Not this. Oh, where is it? Terrible. Did I even do it? Now I'm kinda confused. Part 2 might be in part 2. Okay, let me check part 2. Oh, this one. Try this one. This. Part 2, part 1, the first question. This is what I want you to try. And another one, hold on, let me find it. Those are all in my videos. I just not sure where they are. So let me look for them. Da 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 da, blah blah blah. This is elimination as well, so hopefully you know how to do it. It's quite long. Thank you. Did you guys hear my cat just said bless you to me? I don't know why every time I sneeze, he's gonna be like, ah. Yeah? Did you hear her response again? My cat is quite funny. Where is it? I wanna show you the proof of inverse or identity is unique. Not sure if you've seen that proof before. So that's the one I'm looking for, but I don't know where I proved it. Oh, I have image here as well. If you want more review. So I have image questions here as well. Many different ones. Oh, I think I'll never be able to figure it out. So here is another image question, which has two variables as well. So you can have a look at this. This is part 2, around 56 seconds. So this is another image question. I think I made it up. I think that's it. So I was looking for let me take this question. I was looking for, oh, this was Daria. See, do you recognize Daria's handwriting? I was looking for the unique thing. I think once I find it, I will post down Quarkus, but now I cannot find it. So whoever note down the questions I mentioned, please share with other people. No, I don't think it's gonna be on your quiz. You guys never talk about it. Before, sometimes they test people on this, but nowadays, barely. Okay, so whoever noted down the questions I mentioned, share with other people, please. And other than that, unless you have any specific question, I think we'll end now, because I do not want it to be super long. In the fall tutorial, there is a question you said to look at field part 1. I cannot find the solution. Field part 1. Let's see, where is my field part 1? Why does my videos have ads? I'm kind of confused because I never monetized it. This is kind of weird. Yes, I will do that, don't worry. Let me quickly go over because I recorded a long time ago. I do not remember. Do I remember anything? I don't remember doing this at all, guys. It's probably we're probably asking the wrong person. Did I do this? I don't remember. Whatever. It's whatever. in that tutorial, okay, you guys help each other because I do not remember what is in my video because this was a long time ago. So I don't know what I covered. So you should probably ask each other. Ask whoever watched the video recently. Ask them. Otherwise, I don't know. I really don't know what I did. Anyway, I think we're good. We're good. The file, the file we just did, Sure. I mean, I was gonna finish writing the whole thing and upload, but okay. Might take me a while to get everything done because I told my 132 kids I'll give them a review as well, but I don't even know if I have time for that. My 133 students are suffering as well. I like life science kids, so I will do something for them too. Here. Okay, anyway, help each other. Oh, yeah. This is a question. Victoria, thank you. This is a question I was looking for. Prove tubes and negatives are unique in the field. Yes. I was actually looking for this question. Prove the negatives are filled in are unique in the field. Yes, exactly. That's actually what I was looking for. That's in problem set D. Oh, then you guys should know how to do it. Haha. Okay, nice. Oh, here, it's right here. Negative, there exists W in F such that they add together is, which means negative is unique. Right here. Nice. Okay, I think we're done. Oh, my cat is left me. Can I show cats? Okay, sure. Let me go find my cats. Like you can see my dog too. Show you my dog first. Oh, he's right here. So this is a cat who blessed me. He's not happy. Let me get rid of the background. Okay. Oh. He's really aggressive to my dog for some reason. In my bedroom, specifically. Oh. Okay, don't scratch me. Be a good boy, okay? Be a good boy, don't scratch me. Okay, so that's the first cat. I'll show you a second cat. So here is my second cat. Second cat. Here. Can you guys see her? Oh, here. Not the same cat. So this is my second cat. And here is my dog. Branny, come. Branny, sit. Yeah, they don't like you. Just give up. They don't like you. They'll never like you. Sit down. Good boy. Hip. Other hip. There we go. Okay. There, my dog, his name is Brownie. Brownie? He's a huge boy. He's around 40 kilograms. Yeah. Oh, Brownie. Oh. Brownie is black. Brownie is not called Brownie because he's brown or anything. I named him after the dessert brownie. Because Brownie, he's not a lab. He's not a lab. He's Golden mixed with Bernice. Yes, he still does. Did I show you the video? I think I showed you the video. I do not live on Res. I live in downtown. He is not a lab, by the way. Brownie is black. Yeah, Brownie is Golden and Bernice, half. He looks like a lab. He really likes lab. I did not poke his eyes. Brownie, sit. Oh, good boy. Good boy. Okay, I think we'll end here. Bye, guys. And give him a treat. Okay, I'll give him a treat on your behalf. Bye. Okay, get out. Get out now. Right now. 3, 2, 1.